Now I'll quickly take you through what are the different data science applications, and this is where I would want you all to focus on, to try and understand what is the variety and mix of applications that we see across different businesses. So let's start. um, in here I've put a few businesses, businesses to be precise, but I would want to definitely make a disclaimer saying that this is not an exhaustive list of businesses that can be there, but this is just an indicative seven very important businesses that we see in our day-to-day lives. So if I just take you through what are the businesses we are talking about, we are talking about banking. Banking is where you do your financial transactions, take loans, any financial services. So all that comes under your bank. Retail is which connects you to the wholesaler or manufacturer who sells you the end product, right? Then telecom, of course, our favorite, which keeps up our communication with our near and dear, and also is enabling the world to become a smaller place, right? Insurance industry is basically to plan for any uncertainty that we are going to see in our lives. It could be a vehicle insurance, it could be a health insurance, it could be a life insurance, it could be anything, any planning for any uncertainty we do through our insurance policies. Then manufacturing is the manufacturing industry basically is a broad based industry which deals with manufacturing of anything, starting from your medicines to your automobiles or your airplanes. Anything related to converting a raw material to a finished good is where you talk about manufacturing. Utilities is that industry which basically caters to your daily energy requirements, water requirements, gas pipelines, etc., etc. So those industry which take care of those utility services come under utility industry. And healthcare, of course, the hospitals, the pharmacies, the insurance providers, all that can also come under the healthcare bucket. Now, if you closely see, I have actually listed down a few interesting applications, data science applications. But if you again closely see it further, you're going to see that I've highlighted something in red. Can you see that? I've basically highlighted a data science algorithm, not an algorithm, it's a data science method called fraud detection. So fraud detection is there in banking also, it's there in retail also, it's there in insurance also, it's there in healthcare also, it could be in telecom also, it could be in manufacturing also, it could be in utilities also. So what is the point that I'm trying to tell you? I'm trying to tell you that fraud detection is basically to identify any anomaly detection, including fraud detection, can be a method to identify if there is any deviation from the set processes. So it can be very challenging from a data perspective because it's a bit like finding a needle in a haystack. That is, most interactions are not fraudulent, right? 100, there are 100 transactions, maybe one would be a fraudulent one. So it is just like finding a needle in a haystack. So therefore you need strong business strategy applied and combined with strong machine learning models which could unify and produce the required results. Here I would want to emphasize on the point that understanding of business is as important as understanding data analytics, or if I have to say, it's more important than understanding data analytics. The reason being, data analytics cannot be a standalone business for any in any major businesses that I'm talking about here. It cannot be a standalone entity that can exist independently. As long as it doesn't embed itself into the business, it is not useful. I hope you understand that. Therefore business knowledge is as important as data analytics, and the way you stitch it together is going to bring you leaps and bounds of success. So let's now deep dive into what is fraud in banking. In banking, fraud detection is a critical activity that can span a series of fraud schemes and fraudulent activities from bank employees to customers alike. It could be phishing, spear phishing, account takeover, SIM swapping, hoax site, and what do you do? What do you make use of as data analytics professional? You will be making use of cash transactions that are happening. You'll be making use of the customer profile. You'll be making use of customer demography and many other features to basically identify if there are any anomalies in your banking transactions, banking fraudulent or fraud detection in banking. Let's now talk about retail fraud detection. Fraud detection is a critical issue for retailers as well, because it needs to be determined to prevent losses and preserve customer trust. Fraud can originate from customers or people camouflaged as customers, store associates, or external criminals or hackers. The most prominent recent frauds have involved stolen credit card information, fraudulent merchandise return, or fraudulent billing activities, etc. So here we use transaction activities. The data we use is transaction activities, purchasing data, accounts payable, point of sales data, sales projection, warehouse movement, employee shift records, returns, store level video. Then we have traceability of our goods and services, video and audio recording, and other data sources. That all this could put together can help you identify any fraud that is happening in your retail industry. Now let's talk about healthcare. Healthcare is where people's life is at stake. So people are very sentimental about healthcare. When I talk about hospitals, people really get sentimental about it. So if I have to say it this way, when it comes to life, people trust their doctors, and they can go to any extent to get themselves healed. However, here the ethics of the healthcare provider and the doctor are very important. So wherever there is an ethics angle, that's where cheating could happen. That's where fraud could happen, right? Therefore, frauds are very rampant in this industry, and the types of frauds could be kickbacks, where doctors receiving gifts or gift money, or some other illegal transactions from pharmacies, or maybe some diagnostic centers to promote their products or services. Or it could be medically unnecessary services. So if I'm going for a flu treatment and I'm getting a COVID treatment done, then that's a medically unnecessary service, right? And then there is something called as upcoding. Upcoding is where we are generating bills for no services that were rendered to us. Then let's talk about insurance fraud detection. So insurance frauds affect not only the financial health of the insurer, but also innocent people seeking effective insurance coverage. So fraudulent claims are serious financial burden on insurers and result in higher overall insurance costs. So they could be medical billing frauds, claims frauds, life insurance frauds, and many others. Now let's take an example of medical billing fraud. Medical billing fraud is where you design your algorithms to identify if there is any excessive billing for the same diagnosis and same procedure. You'll try to identify excessive number of procedures per day or place of service per day, and identify multiple billings for the same procedure for the same date of service. Highlight any upcoding of procedures, statistically outlying numbers. Locate age inappropriate treatments, like if you're too young and you're getting a treatment which is for old age people, or you're too old to get a treatment to get polio drops, then that's where that is going to trigger a alarm for you. Then you'll identify duplicate charges on patient bills, find doctor and patient belonging to the same residential address, right? Now we've seen that fraud can mean different things to different businesses, but at the end of the day, what we are trying to do is we are trying to do an anomaly detection, right? Therefore, what I would want to make you understand, dear participants, is that though it means solving a different problem for different industries, the methodology is more or less the same, but the data is where all the magic is. That the data is very, very different when it comes to different industries, and the frequency of data and the number of claims that you see are going to be very, very different, right? So this is where I would want to say it's like unity in diversity. You have diversity of businesses, but you have unity in methodology. Now let me, since I've talked to you about our general banking, let me talk to you also about capital markets. there are multiple frauds that can happen in capital markets also, including circular trading, where there are localized circulation of stocks. I sell stock, somebody else buys it from me, that guy sells to the third person, I buy it from the third person. So we are inflating the stock value internally. So that's a kind of fraud that is there. Then there is pump and dump, where the owner only keeps on buying his own stock to inflate the stock price. Yeah, so TCS has made a solution had made a fraud model for SEBI, and it has been implemented by SEBI. It's a very successful model where we try to identify any frauds happening in the capital markets, that is the stock markets. Now let's also now focus on let's say I'll pick 2 or 3 use cases from let's say since I've talked about banking, I'll talk a little bit on telecom, a little bit on manufacturing, and maybe I'll close it there on the data science applications part. So in telecom, let's talk about a story from a customer from one of our customers, and this is a customer churn model that we had made for one of our telecom customers. So the increasing rate of customer churn has been a biggest threat in telecom industries, right? So especially we have seen that in when the Jio had come into the industry, and almost everybody tried to flee to Jio, and that's where Airtel, Idea, and all, they have lost their businesses. So it is not only dragging the customer base down, but also affecting the revenue base and impacting heavily on the market share. The objective of the model that we had created in TCS was to identify potential postpaid retail subscribers month on month basic who can port out in the coming period. So we wanted to identify those people who are going to go away from us, right, from the telecom industry. So the data that we tried to use was demographic data. So this is where I would want you to focus on. What is the different variety of data that we have used? We've used demographic data, customer profile, revenue data, CDR data, complaints data, network data, campaigns, historical port out information. And the tools that we had used were RStudio, RShell, Spark, Hive, Impala, Netezza, and the algorithms that we were used were AdaBoost, Ridge, Lasso, C5, GBM, Neural Network, XGBoost, Random Forest. Doing and creating the algorithm and deploying it successfully at the customer's end, we could save a revenue of 3.95 million Malaysian ringgit. So this was for a Malaysian customer. We could actually save 3.95 million Malaysian ringgit. So you understand the quantum, right? A machine learning model could save so much revenue for a company, right? Now let's move on to my favorite area, which is manufacturing. Since I am a mechanical engineer, I deeply connect to use cases that come from manufacturing. So this was for a leading chemical manufacturer. We tried to do a demand forecasting model. So this particular chemical manufacturer had numerous types of products that he was creating. So in technical terms, these are called as stock keeping units or SKUs. So he was producing numerous types of models, numerous types of products. So what happened is, it was very difficult for him to estimate what is the exact demand going to be in the future for each of the product type, right? As you diversify your product portfolio, your demand forecasting error will keep on increasing, right? So we had to develop a hierarchical forecasting model that could give a higher accuracy and a prediction power in order to improve the overall supply chain performance. So for this, we had used historical demand data, and the data size was about 1 GB, and the tools that we were used was SAS, Teradata, and MS Excel, and we could actually save $10 million per year for this particular chemical manufacturer. So that's a huge quantum that we had saved for them using a data analytics intervention. Now let's talk about inventory management. So building a safety stock predictive model. So in inventories, basically you are going to maintain inventory because you want to make sure that your customer service levels are high. right? You're able to, whenever there's a customer who's coming, let's say I have a basic grocery store and somebody is coming to buy a Surf Excel, and I'm going to tell him आज मत आना, कल आना, मैं कल स्टॉक लेके आऊंगा. वो कस्टमर क्यों रुकेगा मेरे लिए? He'll immediately flee to another grocery store and buy the product from there. Therefore, it's important for me to maintain the right level of inventory, which is the stock in my manufacturing plant or at my dealers and or at the warehouses, so as to serve the customer at the right time, so that I don't lose my customer. So we built a safety stock predictive model to optimize inventory holding while modeling uncertainties due to supply, demand, new product and part characteristics, while maintaining or improving as a service level. So this particular model that we had done had reduced the inventory management cost to $0.23 million and held the customer safe a lot every year. Is there a question? I could hear some sound. Okay. I'm assuming there's no.
Later on for question answers.
Yes.
We are going to give them time later on for the question answers.
Okay, sure.
Okay. Yeah. Sure.
Okay. So the data that we used for this inventory management was daily audit data, part characteristics data, RAND data from almost 2 years, and the tools we had used were Python, R, and MS Excel. Then maybe I'll take one more example and then I'll close it. I'll wrap it up on data science applications. Another very interesting example which comes and which is very talked about is predictive maintenance. So our client was one of the largest engineering conglomerate in the world. The customer wanted to eliminate any unplanned failures so as to reduce maintenance and service costs. So we had created a machine learning model to do predictive maintenance of turbine fuel nozzle failures of a gas turbine, and we could reduce 95% of unplanned maintenance events, and we could save $12.3 million. Right, so that's a huge saving that we had given for our customer. And the data that we had used were turbine parameter data around exhaust flow, temperature data. I hear some noise. If there's a question, please stop me. Or if there's no question, can the audience please?
It's not the question. There's some voice which is coming out, right? Just hold on.
Yes, I think somebody has unmuted their mic. All right. So I'll continue. So we had used the historical parameters data of the turbine to establish and create the predictive model. Now, in all these use cases, it was not done by a data scientist alone. It was done by a group of people who would understand data, who would understand the business, who were the subject matter experts in understanding the business problems. So all put together, that's one team that works together to create a solution of data science.